So who here uses Netflix? Show of hands. Great. Anybody here not using Netflix? All right, got a couple folks here. We'll circle back with you after the talk. So for those of you who have not been using Netflix, this is what it looks like. So every time that you're on your phone or your laptop, your TV, every time that you're interacting with the Netflix application, getting a movie recommendation, clicking a button, searching for a show, you, or rather the Netflix application on your device, is talking to one, probably several of the thousands of services that make up the Netflix experience. Each of these services has hundreds, thousands, maybe even tens of thousands of instances running. And what are all those instances running? What is Netflix actually running on? Well, most of Netflix is actually running on Java. And that's a lot of Java. I should point out that this is not actually Netflix's service graph. This is not what it looks like. It's more of a representation of what it's like. But the main point here is that we are running a lot of Java. We do use other languages, but since this is not JavaScript 1 or Python 1, we're going to focus on the Java, or at least on the JVM. We're not going to get into too much detail in terms of what all these services are doing. Hopefully, many or most of you were able to catch our colleague Paul Baker's talk yesterday, how Netflix uses Java. If you haven't, please go back, watch the YouTube recording of it once it's published. It'll take you in great detail into how we are using Java at Netflix. So where are we running all of that Java? Well, for the most part, we run all that Java on AWS Web Services. We've been on AWS for quite some time, and it is usually working great for us. Sometimes, however, infrequently, it doesn't go so well. And we run in a bunch of regions across Amazon. So when something does go wrong, let's say in a region, we shift a lot of traffic away from, say, a problematic region to the other regions that we're running in. And that's a lot of traffic. Most of those JVM-based services will just auto-scale up, launching new JVMs to handle the sudden increase in traffic. And our customers, most of you, except for the 3 or 4 who raised your hands, hopefully won't notice or see an interruption in services. So yeah, most things just magically auto-scale up. We just launch more and more Java virtual machines to manage that traffic across all the rest of the regions. However, we do have a number of applications and services that have slower startup times. Slower startup times that prevent them from being part of our auto-scale infrastructure or part of those pools of auto-scaling. So what do? We still need those services when we fail over into these other regions. We need these services to be up and running so that you can all continue using Netflix, watching your favorite shows, et cetera. So our answer to that is not exactly rocket science. It's pretty basic. For those services that are too slow in startup to actually auto-scale on demand, we maintain clusters of those instances, of those JVMs running those services, idle across every region that we operate in. It certainly solves the problem of how to sort of keep or to fail over and avoid and have that responsive scaling. But it's pretty expensive. We're keeping these idle JVMs in every region. We need that because we don't know which region is going to fail, obviously, and we need to be able to manage a lot of that traffic across all those regions and instances. So we on the JVM and Java platform teams are extremely motivated to work on improving the overall startup of our applications. Because especially for that population of services that are in that idle capacity pool that have that startup time, or have startup times that are sort of above that threshold to do auto-scaling. For every service we can move out of that pool, there's a lot of money we're saving Netflix. So imagine our excitement when we first heard about Leyden. Why were we excited? What is Project Leyden? I'm sure that many of you in this room know what Leyden is or quite familiar with it. Some of you may be already running Leyden in production. But I think one of the things that I love about JavaOne is that along with folks who might have been working on the JVM for 25, almost 30 years, there are a lot of folks out here who are just sort of beginning their journey in the Java language. There's probably also a few managers like myself out there who have no idea what's actually happening. But let's talk a little bit about what Leyden is. So first off, I was a bit confused as to what the heck a Leyden was. Well, this is a Leyden, or a Leyden jar, as far as I understand it. And a Leyden jar is sort of a precursor to batteries or capacitors, invented or discovered in the late 1700s. And it's a thing that can store electricity that you create now so that you can use it later. At least that's my understanding, but I am not an 18th century electrician, so check out Wikipedia yourself and get the full story there. Okay, back to present day Project Leyden. The goal of Project Leyden is to make your Java apps start up faster and get faster, to get to that peak performance faster. Again, we're not going to go into a ton of detail here, but at a high level, it allows you to take a bunch of operations that occur during the startup of your JVM and do those things ahead of time before your service can start taking traffic. Some of those things like class linking and loading are a significant part of an application startup. And those can now be performed ahead of time or AOT. We're going to refer to AOT quite a lot in the following slides, so just good to understand that means that we're doing things before we launch our production JVM. So for Netflix, it was apparent that doing more things ahead of time would be a great way for us to improve that startup time for our relatively slow to start applications and services. And we were experimenting a bit with Leyden in some of the early access releases, and then in 24, and now in 25, and we really have seen some pretty compelling results. So we were really bullish on what Leyden could deliver, but to be honest, there were a few steps missing. There's a bit of a gap going from those two circles to that full owl of a Leyden-enabled application running in production. A few gaps for us to take advantage, especially in a large, complex production environment, of Leyden's approach from shifting parts of the startup to AOT or ahead of time. Leyden is ultimately a lot more complex than just adding a flag or just finding new parameter values or tuning a new behavior. The nature of AOT, of things happening outside the scope of runtime, brings more complexity than the usual JVM enhancement. There's some really great guidance on the Leyden project site about training and the overall mechanics of Leyden. But there's not a lot, understandably, about how to operationalize Leyden in a production environment. This is a feature, not a bug. Every large-scale Java deployment tends to be a lot different. Everybody's path to production, those deployment pipelines are going to vary quite a bit. And we don't want the JVM to be prescriptive about how we have to stage, shift, operate, and productionize our JVMs. But we want to build on those core foundations, that core value that Leyden is able to give us. My colleague Martin is going to walk you through how Netflix actually tackles the sort of the operationalization, the productionizing of Leyden in our environments. And hopefully for some of you, you'll find some useful sort of tips or guides. And we're more than happy to chat with you folks afterwards to talk through how our experience might differ from yours and some shared learnings across the way. So without further ado, I'll turn it over to Martin.
Thank you, Ian. Now, when we understand a little bit more about Netflix Java ecosystem, let's see how we use Project Leyden. Let's draw. Here are the Java AOT equivalents of those two first circles. Our first circle, the first Java AOT flag, will instruct JVM to create recording and capture the training for us. The second circle, the second flag, will instruct the JVM to use the recording and hopefully get all the benefits of the training we just captured. Now, the second step on our journey is our own beautiful Netflix owl. Our startup time improved between 15 and 20%. I'm sorry, I got carried away by the owl analogy. You are probably here to learn a little bit more about the details, how we achieved that. So, let's start at the beginning again. Our primary goal is to figure out where are we going to use those two flags. The second one is pretty obvious. We want to use it in our production. But where are we going to use the first one? Where are we going to capture the recording? The general rule is that we want to do the recording as close to production as possible. However, before we will start figuring out where we place our recording flag and where we capture the training, let's review some requirements we need to fulfill between the recording place and the usage place. Because sometimes if we break them, the recording won't be able to be done, or the usage place will not allow us to use the recording. The first requirement is around class path. Our class path needs to match between the usage and the recording. And it cannot contain any directories with class files. It needs to be fully packaged jars. The second requirement is that the JVM version needs to be exactly matching between the recording and the usage place. And not just JVM version, even the JVM configuration needs to be the same. For example, our selected GC algorithm. The third group of requirements is that our operating system and CPU architecture needs to match. And again, there are some details, not just CPU architecture in general, but even certain CPU features that are available needs to match. For example, available vectorization instructions. As I said, typically if you break those requirements, the result is not catastrophic. Your application will still start, but you will not get the benefits of AOT. Now that we know the requirements we need to fulfill, let's take a look at typical Netflix application deployment pipeline and see what would be the possible best place for us to capture the recording. The first place we will look at is a local build. Our application should be covered by tests, and they should exercise all the important code in the application. If we are able to capture the recording here, the potential benefit for us is that any later step in the pipeline would benefit from the recording. Sadly, that's where the good news are ending. Because if we take a look at our requirements, we will not fulfill the class path requirement because our local build will produce classes in directories. We will not fulfill our system and CPU architecture match requirement because on local we often have MacBooks, on our production we have Linux. And we even break the requirement with the exact JVM version match. On our local build we can guarantee the match of major version but not the exact version match, and we will also not fulfill the requirement of the exact JVM configuration. So not the best place. Let's keep looking. The next step is CI build. On this stage, we would get the match of CPU, possibly, if we do some configuration. We would have match of the operating system, but that's about it. Again, we cannot guarantee the exact JVM version match. We cannot guarantee the JVM configuration match, and the class path, again, will have some directories with class files. The third step is deployment to test. Now things are becoming more interesting. Because now we do have match of CPU architecture and operating system. We can guarantee the exact match of JVM version and its configuration. And our application is fully packaged class path with only jars on it. However, the problem is that our test will not see sufficient or exactly matching load as we would later see in our production. So the training would not be the best representation of the workload we see in production, and the gains won't be as good. So let's push a little bit further and look on later stages. So the last stage for us is production deployment. But wait a minute, isn't that the place where we want to use the recording? Can we record and use on the same stage? Well, in theory we could, because our production deployment is not constant. When we deploy a new version of our application, we could capture the recording, and then when our customers are coming later at home and want to watch some Netflix and our demand is increasing and we want to scale up, that's where we would use the recording for those instances that are scaling up. And nothing has as good production load representation as the production itself. But even this stage has some troubles. The way how we would select the candidate for the recording, how we would terminate it, how we would capture the archive and distribute it to other instances, that introduces too many changes to our way how we currently deploy instances. And so we again decided not to use this stage. Now we might be thinking, where did we actually capture the recording? I was a little sneaky and I did in one more stage in between the test and production. We call it canary testing. Let's review our requirements again. We do have matching CPU architecture and operating system. We can guarantee the exact match of JVM version and its configuration. We have fully packaged class path with only jars. And this test will see the exact same traffic and workload as production. And this canary test has a very natural fit for any type of training because it has explicit duration and ending. It is already very well integrated in our deployment pipeline. And we have good points for us to add our logic for capture the AOT archive and distribute it. Remember, at the beginning, I said that our goal is to capture the recording as close to production as possible. This is where we got, and we call it just in time, ahead of time. Now let's dive into details how we actually got integrated into this deployment process. Our team is not just taking care of JVM-related things at Netflix, but we also own build tooling. And this build tooling is responsible for creation of application startup scripts. That way, we had good leverage to modify those scripts and add our AOT handling logic in the application startup script. This diagram shows at high level what the script is doing and how we handle the canary testing. While the application is starting, we use environmental variables that contain all the details about cluster, and based on naming conventions, we can figure out if we are part of canary cluster or not. If we are, then we start our special AOT orchestrator process. Then we start our main application. Then the AOT orchestrator process is waiting for the main application to finish the canary testing and terminating. And then when application is done and we have the AOT archive, the orchestrator will also upload it to our storage. In this process, I would like to spend some time talking about different steps. And the first step I would like to describe a little bit briefly in more detail is how we actually handle the end of the canary. Our AOT orchestrator is watching for the main application to become unavailable over network. Because when the canary test is done, we have canary testing platform that will unregister the cluster from our service registry and will make it not available. And that way, our orchestrator will discover that canary has ended. When that happens, the orchestrator will issue a graceful termination signal to the main application, which will trigger all the processes to create the AOT archive. And when the application is done with the termination, it will have the AOT archive locally on the disk. The AOT orchestrator is waiting for that, and when it sees the file on the disk, it will upload it to our storage. This is how we handle our upload. Again, a couple of interesting steps going on there. The first one is how we generate the name for the archive so we can later discover it in production. For that, we use, again, environmental variables that contain all the data. And we take application name and cluster details from that place. You might be thinking, why not just application name? The reason is that in our case, we can actually deploy same application on multiple clusters, and each cluster have slightly different workload. So we really want to ensure that our training is matching the exact workload. That's why we use additional cluster details in the archive name. And the third part of the archive name is hash of the class path. So we can also ensure that we are matching the class path between the usage and the training place. The second step is how we compress the archive before we will upload it. For that, we have chosen a Z-standard algorithm because it has a few very interesting features for us. The first feature that we are using is that Z-standard can compress and decompress independent data frames from the file. You don't need to wait for the whole compression to happen. And we use that because as soon as we compress enough data, we can fill the part for the upload and start shipping it to our storage, to S3. That way, we can nicely parallelize the upload and make it done as fast as possible. This slide shows how the final part looks like, how the final file looks like in our storage. And it actually shows the second feature from Z-standard that we are using, and that's the algorithm supports special metadata data frames that are being later ignored by the decompression. And you can store custom metadata in them, and we store there our input position, which is a place where the data originally came from in the original archive file that will later help us to reconstruct the file during the download phase, which we'll describe later. And the last part has even more metadata that contains security-related things. You might be thinking, what happens if there are multiple instances in Canary cluster? Then it's simple race, and whoever is the first one to create the archive, that instance won, and that will be used. So you can see we put quite a bit of attention to ensure that we can do all the decisions locally on instance and avoid creation of any central service that would be orchestrating the whole workflow. The upload is a fairly simple process, but it already gave us fair amount of interesting lessons. So let's go over them. The first group of lessons is around process termination. I'm not sure if you remember, but I said the orchestrator sends graceful termination signal to the application. And in our experience, the application termination is sometimes a little bit neglected part of the application lifecycle. You can always sick kill it and be done with it. In this case, that's not true. It needs to truly gracefully terminate. So if your application has some sort of non-daemon threat hanging around and blocking your application from termination, that's something that needs to be resolved. And without it, you won't be able to benefit from the feature. The other lesson for us was, even though our deployment pipeline was very well prepared for us to get integration done, at the system level, we were not as ready. So when our main application terminated with the archive nicely sitting on our disk, our upload tried to start, but our OS killed the upload sooner than we were able to finish. In our case, we are using systemd to manage our processes on instance, And so we needed to adjust a little bit of the configuration to ensure that our orchestrator survives long enough to finish the upload for us. We believe that a lot of those problems we will be able to avoid by using a new feature that is coming to JDK 26, or came to JDK 26, which is a new J command action that allows you to terminate the recording, but keep the application alive. The nice thing is, I believe that this will be even backported to JDK 25 in some patch versions, so even JDK 25 will be able to use this for our benefits. And that way, you don't deal with process termination, and it will greatly simplify the whole end of the canary test because you won't be needed to orchestrate that many processes. The second lesson for us was around the way how JDK handles those AOT flags. If you were following Project Leyden, before JDK 25, you had actually needed to do 2 JVM invocations to get your AOT archive. In JDK 25, there is 1 JDK invocation, but it's just a facade, and underneath you still are doing those 2 JVM invocations. They are just done for you. The little kicker is that those 2 JVMs run at the same time, and the second one will inherit the same JVM arguments from the first one. So if you are like us, giving your application 75% of instance memory as a heap, and you use always pretouch, you are for a fun ride, and it will take you, or at least me, took quite a bit of time to figure out what's going on, and eventually discover that I'm getting killed by the out-of-memory killer because I'm oversubscribing my memory. The fix is fairly easy. There is an option how to override these arguments, but you might hit it. Okay, let's get back to our AOT main process. Our canary test has passed. Our AOT archive sits happily in S3, and we want to use it. How did we get it done? It's not surprising that we again integrated the logic into application startup script. This time it's a little bit simpler. While the application is starting in production, we just start our downloader tool, and if we detect there is an archive that is matching our application name, cluster details, and class path, then we will download it, and we will start the JVM with it. Now, a keen observer might say, but Martin, your download is now on the critical path for the application startup. And that's true. That's why we spent quite a bit of time to figure out how to make it as fast as possible. As a reminder, here is the structure of the file in our storage, in S3. And as you remember, I mentioned that we store, at the beginning, each data block, we store an input position that was the place where this block came from the original file. Because now, what it allows us to do is that we can start download of each of those parts completely independently in parallel and stitch the final file in memory. And there is no waiting for ordering of those parts. We also try to detect the available network bandwidth we have on that instance, and we spin up as much connection as possible to fully fill the network bandwidth we have available for that instance. The caveat is that some of our instances have so limited network bandwidth that we could open only one connection, and in that case, this parallel approach has quite a bit of overhead, so we implemented a fallback pathway that uses just single request, single stream download, and that in those constrained environments performs a little bit better than this parallel approach. Now let's spend a little bit of time about security. If you remember, I said that the last data block of the file has some additional metadata block at the end, which has security-related things. Now we are going to use them. Luckily for us at Netflix, we have some aspects of that already solved because every single instance of the application from Canary to production will have access to application identity. So when we are uploading, we create a cryptographic digest of the uploaded file, store it in this metadata block, and sign it with the application identity. And then, when we are downloading, we can reverse that. We can verify the signature of this metadata block, and then ensure that the actual downloaded file has the same digest as the digest we stored in the metadata block. That way, we can ensure that nobody tampered with our file on our storage. How about encryption? As far as we know, there is nothing sensitive in our AOT cache files, so we have decided not to encrypt at all. If that changes, we can change our approach. Well, I've been speaking about things we have done quite a bit, but how are the results looking? If you remember, I promised you improvements between 15 and 20%. Did we get there? Here's some data from application we have benchmarked. And at the baseline, without no AOT, the application started in 50 seconds. When we captured the recording during the Canary test of this application and used it in production, we were able to bring it down to 40 seconds. Unfortunately, our startup time metric is not capturing the download time, so we needed to account for it manually, which was in this case 2 seconds. So we have 8 seconds net benefit application startup time, which is in this case 16%. Speaking of download, because we put quite a bit of attention to improve the speed of it, for this application, the baseline was 2.5 seconds for just single connection, single stream download. And when we applied our parallel approach, we were able to bring it down to 2 seconds. This assumes we have enough network bandwidth to actually parallelize it. Okay, part of the promise of Project Leyden is that you will improve startup time, but you will also improve warm-up time from the first request to the peak performance. Sadly, for the applications we have been testing and the state of AOT in JDK 25, we were not able to get good data that we would show you today. Sounds disappointing, but for us it's sort of expected because we believe that the biggest feature that would help with warm-up time has not been delivered yet. And that's caching of compiled code. Because today, your training run will capture the profiling data, but your production JVM still needs to use the profiling data and do the compilation itself. And so when JDK captures the compilation during the training, the production JVM will be able to hit the ground running much faster. So keep your eyes open for the open JEPs. We believe this will be the feature that will actually make the cut and make a significant improvement in the warm-up times. What's next for us? This is the current state, but are we done? We are of course not. Here is what we are planning to do during this year. Well, first, we want to enable this AOT workflow for any JDK application that has JDK 25 and is using Canary testing. We want to use our central team leverage point to do that for the teams and allow multiple teams to get benefits from it without spending their own time with it. We also believe that the improvements in JDK 26 and possibly later patch version of JDK 25 will broaden the scope of the applications we can target, because as I said, the J command action that will allow us to end the recording without process termination would be a huge simplification. And for example, we could start doing the recording during our test deployment and then use it in production. That way we can include applications that, for example, don't have any Canary at all. We believe in general this is very good investment for us because Project Leyden will keep improving. once we have this infrastructure in place, we will immediately start seeing the benefits from any future JDK release that will happen, and most likely we will not be needing to do any additional work. So why not have one additional carrot for our engineers to adopt new JDK version? The other slightly lower level stuff we want to focus on is how we can move the download step from the application startup to avoid being it on critical path. This is the current state. The one approach we are currently exploring is to move the download a little bit earlier when we are initializing the container, and there is a couple processes going on at the same time, so we can sort of hide our download time behind other steps that needs to happen anyway. However, in this case, the download will be still subject of network limitations given to the container. So ultimately, we are thinking about moving it even sooner and have some sort of AOT cache sidecar that would have the AOT archive built in the image. So when the image is pulled in, the application would see it as locally available. And the image pull will again happen in parallel with other images being pulled, like the application itself and other sidecars. And the image pull is not subject of network limitations of the container. So we could get the data on the instance much faster. Well, we've been drawing for a bit, so how the final picture is looking? Well, I promised you this owl, but in reality it looks more like this, and we still have a bunch of work ahead of us. We mainly want to get the feature as widely spread as possible at Netflix so we can get the benefit out of it in the future. However, even at this point, I can say we have some good takeaways we can give you. First, the application speed-up gains are real. Those are no pet store applications. Second, we were able to implement the feature without any sort of central service. We use only locally available data on the instances, and we could avoid a lot of complexity by doing that. And lastly, we were able to use existing integration points and existing workflows at Netflix to get the training in place, namely our canaries. So think about your processes and your places. Where would be the best place for you to apply this training and use it? I hope you enjoyed the details of our approach, and we will keep you posted how we will fill the rest of the picture.
We have a minute or two for some questions, so please go ahead.
Just a quick one. How big is the AOT you have at the end? Because I'm surprised you need to compress and it's a challenge to upload. So is it that big?
It's not that big, but especially the download speed was concern for us. So we wanted to make it as small. We wanted to make it as small as possible. So even though it's a couple hundred megabytes, the Z standard is so good that it will make it like 10%. So it's 90% reduction of the size. It will make a dent on the download speed.
I think also there's a lot of services out there downloading and doing it. There's a lot of traffic happening. So even the small compressions, ultimately, as long as they're more efficient than the compression, decompression, work out pretty well for us.
So we're in the range of 200 megabytes, which is not that small, actually. It's sensible. Okay, thanks.
Thank you so much for the talk. I think you highlighted some of the pain points really well. And would you agree that one of the things that we could enjoy a lot more is if AOT cache was not representative of the application, but rather representative of the kind of a collective set of caches for each jar. For example, your application has 50 jars. I understand that in the process of JIT compilation, they cross the boundary through inlining and whatnot. But it feels like I would much rather trade a bit of that efficiency for the sake of having AOT caches like per jar level and have that fetch, because you have like, I don't know, 20 applications and they use 50 different jars or 100 different jars and in some sort of a mesh form. And it would seem like from a practical perspective, we have like Leyden people, developers here in the room. So I think that sort of disconnect with like what you envision and what really happens in industry, like you've shown at your talk, I think that's kind of a feature we could request.
Yeah, I think we can defer to some of that stuff to the Leyden folks on some of the core operational aspects, but I would say just as a large-scale operator, having more things to manage throughout this process probably doesn't seem great from our perspective.
I would counter that. It's I don't know about your experience, but for me, the biggest headache is that there are so many applications, there's so many configurations, that ideally, I would like to have a way to shove some of that AOT cache associated with a given jar into a jar itself, because then in this case, in deployment, I would not have to actually modify. They would still use kind of the same jar path. But I understand that the jar has essentially hash code, and it would basically reject as soon as I modify the jar itself.
Yeah, we can take it offline and chat more. We'd love to hear some more about your ideas there. So.
To comment on that, I think that's something that was on one of the last slides of the future that Dan discussed in the presentation before us, and that's more allow maybe not necessarily like jar level, but like platform level. So for example, if you are using Spring Boot, your Spring Boot jars would be already AOT'd by Spring Boot team, and you would already get benefit across all the applications. So probably not at the level of jars, but at the level of platform. So in our case, for example, interesting case is Spring Boot or Spark, for example, because you share a lot of infrastructure among the jobs, but they are not always the same. So you could at least AOT a common part.
Very quickly, Ian, I appreciate the K-pop Demon Hunters t-shirt. It's also appropriate, of course, Netflix property. But more seriously, my organization has some workloads that are on Graal VM. My guess is that Graal just wasn't very useful for you guys at Netflix, because for you guys on Java platform, you need something that's going to work for everybody. So the idea of, hey, this is all going to work provided you make all of these changes, that's just a non-starter for you guys, is my guess, right?
Yeah, great question. I think we expected someone to ask about native images on Graal VM. You do get a faster startup from that native image, but three things I think pushed us towards the Leyden AOT. First off, a lot of these services are long-running, larger Java services. We don't want to trade off startup for long-term JIT optimizations and sort of the flexibility of the dynamic nature of the JVM. Again, startup is important to us, but more important is obviously that peak performance of the application itself. Two, the operational complexity of getting to that full closed world sort of, Graal native image is a lot of work. We're trying to do this for 3,000 different services and applications. Getting to the AOT for Leyden is obviously some operational work, but not nearly as large a lift as what we would have to do to get across all our services, evicting all the reflection, that kind of thing. Lastly, we're the JVM and Java platform team. We're building out and operating sort of that core infrastructure for the actual operators and customers of that service, changing the runtime aspects of their service across all of Netflix fleet would take us a long time to get our operations folks and everybody on board. That said, look, we're big fans of the Graal projects. There's lots of great stuff coming out of there. Native image is great for a lot of things, smaller tools, things that are sort of not in that larger service graph. And then all the other stuff happening in Graal is pretty exciting too, Truffle, et cetera. So big fans of Graal in general, but not the right thing for us here. And a great question. So.
Thank you both for the talk.
Yeah, thank you so much for the talk. My question is, since you're training in the production Canary environments, therefore servicing real requests. Was there any CPU or memory overhead during the training run, and any other overhead that you noticed?
I believe we haven't not noticed any overheads during the recording, at least not measured. Like the way how I was looking at it is the canary has passed, so that means that there was no significant enough divergence between the pure canary versus the canary that would be also doing the AOT training for us.
I think these are performance canaries, so we are looking for deltas in performance from run to run. So nothing that triggered a performance regression. There may have been something in there, but not significant enough for us to be alerted by that.
So does the training run also suffer from the slow start issues that would be present in a normal run?
Could you repeat the question?
When you're training the training run that you're running, would that training run suffer the same slow start issues of a normal service startup?
Yes.
Yeah, it's the same startup script, just with the Leyden commands injected into it. So.
There'd be no AOT startup. Like in that application I showed, it would be the 50 seconds startup for the canary itself. But then the canary is just a very tiny slice of the production traffic, so that's okay for us. And we do them hopefully not during evening hours when everybody is eager to watch Netflix.
Right. Okay. Thank you so much.
Thanks.
Hi, I just wonder, since you have such a comprehensive pipeline for testing your application, I just wonder if you have considered like using this pipeline to test, instead of your testing the application, test against another JDK, such as one build from Project Leyden.
One build from what?
Like for example, Project Leyden has published a few EA builds, even though they're...
Sure.
Yeah, this was production service. I'm not sure if they would be comfortable with... we do have a group of people that are very eager. So yesterday was JDK 26 release. I believe we are running JDK 26 in production today.
Okay.
So if you are interested with feedback, we can make it happen. Probably not with the one I showed on the slides, but there are customers, meaning Netflix engineers that are comfortable with testing.
We allow our applications to run any of the 6-month cadence releases. We wouldn't inject an EA into that process, but like our engineers, like Martine and Danny Thomas and other folks, are deploying those EAs to get that signal. So we experiment with them, but we're not putting those into the hands of our users. If that makes sense.
Thank you for experimenting the EA builds. Thank you so much.
Yeah. And just a quick time check. Are we doing good?
We have 2 minutes left.
Fantastic.
Okay. So you said that there is no benefit we got after the enabling AOT cache in production. Did you try to use AOT compiling early flag where the class is compiled immediately as soon as it's loaded? At least C1 compiled.
Yeah, so we honestly are not doing a lot of evaluation right now of the method optimization or any of the startup optimization is right now our main focus for this. So we haven't done much experimentation in that.
Okay.
I think we're going to wait until we get the actual JIT optimization stuff dropping. That seems like the best win for us down the road.
Okay.
I really appreciate you guys use it in production. This first. Second, I appreciate that you're checking CPU feature, so you're ready for AT code caching.
Yep.
Then third, we backporting J command to 25 update. So one of the update you will get it. You don't need to wait 26. Oh, 26 already out, so you don't need to migrate immediately to 26 when you update. So this is what, essentially, thank you guys for doing this stuff.
Best question we got all day. Thank you so much. And thank you, folks. Really appreciate it.
Thank you.